digital. Our next topic will be quantum technology. Quantum is big, it's complicated, it's huge, and it has fast, and its implications are very, very serious. From geopolitics to research, affecting our work. So quantum, that's why we will put a focus on quantum, because quantum is just a different ballgame. And in order to give you an insight, to shed a light on the newest developments on quantum, we put a nice panel together, ladies and gentlemen, to navigate this song. Please welcome on this very stage Isabell Gradert, Vice President of Central Research of Technology for Airbus, Dr. Morten Bache, Scientific Director von Quantum Novo Nordisk. We do have Dr. Shohini Ghose, CTO of Canada's Quantum Algorithm Institute, and your host is the one and only editor-at-large of TechCrunch. Please, the stage is yours.
Hello, everyone. Great to be back here. Mike Butcher, technology journalist based in London. And we are, obviously, as we've heard just now, AI everything. But now we're going to be doing quantum everything. And I think that one thing that is worth bearing in mind is that we are entering a very different kind of universe when we're talking about quantum computing. A lot of the time, I think that people confuse AI, generative AI, and quantum. And so we're going to try and disabuse you of that misapprehension to some extent. And as you heard earlier, we have a fantastic panel, Isabell from Airbus, Morten, who's with Novo Nordisk, and Shohini from Quantum Algorithms Institute in Canada. But let's just, let me just, our panelists will give you a better definition, but I'll just to set the stage that classical computing, if you remember, is zeros or ones, while quantum qubits are both 0 and 1. But we're going to hear, firstly, from Shohini. You have a fantastic TED talk about this. So for the benefit of everybody, do you want to just tell us again what quantum computing is? Because I think it's so helpful to get us all on the same page. But let's do it in less than a minute or so.
Oh my God. All right. Is this on? Okay.
Yes.
Can you hear me? Yeah, so I'll do my best. I'll just use one of the examples or analogies from the talk that you mentioned. So quantum computing versus classical computing is a lot like a candle versus a light bulb, because they both are doing the same thing, making light. Both computing, whether it's classical or quantum, are about computing things, calculating things, transmitting information, detecting information, same goal. So we're not trying for a different kind of goal. It's still about computing. But I think you will agree that the way a candle works, the technology of a candle, is very different from the technology of a light bulb. So that's the difference between quantum and classical. We're not talking about just one more chip that we're building that's somehow better. This is about a whole different technology. You cannot build a light bulb if you keep investing and trying to make better candles. So you cannot build a quantum computer just by building better chips that we are very familiar with from Apple and Intel and others. Or even NVIDIA will not be able to build a quantum chip just using GPUs. So a quantum computer requires a whole different technology based on quantum physics and the fundamental unit of information, which is called the quantum bit. Hopefully that helped.
Fantastic, and I want to talk to you a little bit more in a moment just about the Quantum Algorithm Institute work. But if I can bring now Isabell from Airbus. Now, I suppose Airbus obviously has used traditional computing as part of its normal day-to-day running, of course, for many years. But give us a kind of a vision of what quantum computing is going to mean for an organization like Airbus.
You know, innovation is really fundamental to our industry. It's really this driving motor for everything, for any progress we have, if it's about competitiveness, performance, or sustainability. So we are continuously monitoring what's going on in terms of technology with more classical technologies, but also emerging one. Quantum is so interesting for us because we see at a point in time that the classical HPC solutions, even we try to improve them on hardware side, on software side, but there is a physical limit at a point in time. So we need to look for more disruptive technologies, and here quantum computing is very promising for us. I mean, we are an end user. Let's be honest.
When you say promising, are you talking about designs of new aircraft or batteries, or I mean, and what's transformational about it compared to maybe designing, say, an aircraft wing with a normal computer?
So with the quantum technologies, that's really so exciting for us because the quantum gives us the opportunity for a wide range of applications. So here today we're just talking about quantum computing, but we shouldn't forget on quantum communication and quantum sensing, and it's applicable for all our product range. So from commercial aircraft to helicopters to the space. So this is really exciting, and therefore we need to engage on that. On quantum computing, we have started already 10 years ago to have a look into it. And we started to understand which are the applications which really could have the highest impact. And there are many of them. And I would say if we are looking time-wise, the topic of quantum simulation is something very interesting. And I think we shared this on a panel here.
You said quantum simulation.
Simulation.
Right. Well, there's something for you to pick up on, Morten. But perhaps, first of all, it would be interesting to hear, now, Novo Nordisk is a big foundation, and I was reading, in fact, that it's larger than, it's the largest private foundation globally, surpassing the Gates Foundation and Wellcome Trust. So you've got plenty of firepower to play with. So what are your plans for quantum with your foundation?
Yeah, thanks. Yeah, we really believe that quantum is one of these transformative technologies that will impact basically all sectors in some way, shape, or another. So it will in some sense be like the AI transformation we have seen over the past 10 years, where we didn't really know 10 years ago what kind of impact AI would have, and now we are seeing it more and more and becomes more and more concrete. We also understand there are some areas that AI will not have a big impact on, and others where it will be huge, and the same with quantum. And we saw that as a foundation 5 years ago, that there was a very large basic science ecosystem in Denmark, and we could accelerate that quite rapidly by investing heavily into this ecosystem. So we have put close to €1 billion into the Danish ecosystem right now as a founder, and I'm trying to reshape the Danish ecosystem in coordination with the government and the private sector. And for us, it's super interesting to figure out with companies like Airbus and Novo Nordisk, other companies that are trying to use the technologies and trying to figure out how can they solve our problems today. And one way to think about it is that when you do computational physics, you always are stuck at some kind of scaling problem that you are never going towards that direction, because you know that the computer memory will burn out, or it would take maybe years to complete a simulation. But with quantum technologies, there are areas where you can really see that you open up for new solutions. So suddenly, as an engineer or as a researcher at a company, you suddenly say, aha, now I have a completely different way of solving that problem that I never thought about being able to solve with a classical compute. So that's the powerful transformation of quantum.
Right, so a lot of it.
And maybe I can compete on that, because I've just mentioned on quantum simulation, which will give us new capabilities in this aspect of microphysics processes simulation, but we also have then the quantum optimization, really are looking on combinatorial challenges we have, thinking about flight trajectories, flight schedule planning, for example. We have the machine learning, and also we have quantum solvers, because you have asked about, where do we see application areas? Quantum solvers may be the one which are most is right, because it's quite complex to use the quantum computers then to solve this Navier-Stokes equations.
So, if I can bring Shohini in, at the Quantum Algorithms Institute, is it effectively it does what it says on the tin? You just make quantum algorithms? Because certainly from an outsider's perspective, a layperson's perspective, one of the issues often I have is that there seems to be so many wonderful things happening much more at an R&D and a scientific level, but at a practical business level, it's still a little bit a ways off in terms of how we apply this stuff. So tell us a little bit more about what you're working on, but also how you see this playing out perhaps in the business world over the next few years, 2, 3, 4, 5 years.
Yeah, so to your first question, so algorithm is a nice broad term. It can mean many things. So the Quantum Algorithms Institute is actually is funded by the province of British Columbia in Canada with the mandate to be bridging that gap that you just mentioned between that R&D piece that's happening across universities, I think in Canada as well in the world, but to bridge that gap to industry as well, and of course also connect to government in terms of policy making and regulation questions. So Quantum Algorithms Institute sits in that sort of intersectional space to try to bring those algorithms into the real world, if you like. So the things we do is we do connect to companies to try to build out what we call feasibility studies, looking at benchmarking, or eventually, of course, that big question, that holy grail of trying to get to a commercial level, real-world kind of application. So we're looking at all these different stages, and I think many companies around the world are thinking about how to get quantum ready, which means that we may not have the
Yes, I'd love to hear more
computers.
about what is quantum ready.
Yes, okay.
Yes.
So we don't actually have quantum computers that are large scale enough right now to be tackling commercial applications at scale. We're just not there yet. I mean, everybody's in a quantum race to get there, of course, and there are some very smart people at some very large companies working on this. To prepare for the time when that large-scale computer is available will require some groundwork. It's almost like, back before we had an app store, nobody knew whether we were going to use our nice little devices in different ways. And now we use it all the time. So we're at that point. We're trying to get ready with our quantum app store. That's what quantum readiness is all about.
Yeah, the way I usually think about it is back in the day when the ImageNet was founded, the hardware was not really ready to tackle all that data. But NVIDIA said, okay, let's try to use some GPUs to tackle that problem. It worked, but the deep neural networks were not fast enough. So the hardware was not fast enough, the data was not fast enough. But didn't mean they gave up. They worked 5 more years, and then they had the ChatGPT moment. And this is where we are right now. We hope in quantum that we are. Everything is sort of in lockstep, trying to push the technology on the hardware side, on the algorithm side, on the data side, on the industry side, and all these things to slowly go towards that inflection point that we believe where quantum will be a wow moment for a lot of you guys here in the audience.
Yeah, absolutely. I wanted to mention as well, we are waiting. So we don't have the quantum advantage today, and we are waiting for this ChatGPT moment. The moment which will change everything and which will even accelerate everything what we have today. But therefore, it's so important for all players to be ready, because the worst thing what can happen is that the quantum computer is here ready to be used, and we have no clue how to do it. We don't know for which applications, we don't know, the programmer can't use it because it's not the same.
What should we be looking for in terms of quantum? In the business world or journalists, should we be looking for the number of qubits or some other number that might signal that ChatGPT moment?
Sadly, it's not. I can't even pinpoint just one number. It's not that simple. I wish I could. Qubit number is important, but it's not everything. You might have 1 million qubits, but if they don't actually work well, meaning if they are very noisy and there's some errors happening, it's not going to help. And if they're working very slowly and speed is an issue, that wouldn't help either. So we have to look at performance metrics that are about outcomes. So I think those are still in the process of being developed. On the readiness front, I do want to mention one more thing, which is companies, even if you're not planning to use quantum directly, you have to be quantum ready in the sense that we do have one application we all know will happen as soon as we have a large-scale quantum computer, and that is in breaking all of our current encryption standards. So everybody here uses encryption. We're all sharing data and information, and once we have quantum computers, our current standards are just gone. So that's what quantum readiness is all about. Even if you're not going to use a quantum computer to do something, you have to make sure you're protected in your data and your information because quantum poses such a threat to your data security.
Yeah.
Yeah,
Go ahead.
I would say that until now it has been that the more qubits, the better, in the sense that we need a lot of qubits to move to the next stage. But the next stage is logical qubits. So it's sort of the phase 2 of quantum computing evolution. And there, sadly, the number of qubits become very few because they are sort of created by a lot of physical qubits. So where you maybe will have 1,000 physical qubits to create a handful of logical qubits. So suddenly you will see stories about 5 or 10 qubits doing the work. And you're thinking, wait a minute, didn't we have 1,000 or 10,000? Yes, but this is because they are high quality logical qubits. So they are error corrected, so they don't make mistakes. And that requires a lot of physical qubits. And that's the next stage of the journey. So there will be a lot of confusion in the media, for sure, about that.
Is there a temptation for Airbus to develop its own quantum computer, or are you more interested in seeing how the field plays out? Surely you must be tempted to try and build your own.
We can build a lot, but we will never build a quantum computer. So we are an end user. So what we're doing is we are looking at the market, what is happening, and on our side we prepare to be agnostic. Whichever technology on the hardware side will be the one making the race finally. So we are preparing to be agnostic for that. And it will also be interesting to understand as well, not only how the hardware, but also the middleware and the software will evolve, because this is also then dependent on how many qubits you need at the end. Huh? What's also important is, from our point of view, is a lot of people believe when the quantum computer is available, we will forget everything what we have today, and we will only working with a quantum computer. We don't believe that this will be the future. So we really see a hybrid system in the future, getting the best out of two worlds, the classical HPC and the quantum resources working hand in hand.
So quantum computing isn't about to put NVIDIA out of business, for instance. Is that what you're trying to say?
I'm trying to say something similar, yes.
Right. Everyone from NVIDIA can breathe a sigh of relief.
Yeah, but they are actually a quite active player in the ecosystem because they don't try to build their own quantum computer. They are enabling others to build it and also to actually operate it, because exactly like I mentioned with the logical qubits, that is a huge orchestration task. There is an AI algorithm that has to figure out what the individual qubits need to do to keep the data qubit, the logical qubit, alive. And that requires high degrees of ultra-high speed processing by the most advanced supercomputers in the world, actually. So they have to coexist to be able to do the computation.
Shohini, you obviously got a very good overview of all of this. What sort of timelines are we working on? Is it possible to predict how things will play out over the next few years or not?
Nobody should ever predict anything about technology because we always get it wrong, I think. As I was saying...
Well, I think Elon Musk told us we'd have driverless cars in 2016, I think, something like that. But maybe his predictions are a little off.
I don't think anyone could even have predicted that we would all have our little pocket devices. I remember in the 60s seeing that in Star Trek, right? They would take out something and pretend to be talking into it. And we do that now. And there's no way we would have predicted that. So I think we're similarly going to get it wrong if we try to estimate what's going to happen with quantum, because we'll always underestimate, because that's a trend that happens.
So there's no timeline at all?
There is. So I think over the last year or two, there's been a lot of progress, as you're mentioning, in error correction and building those high-quality qubits that we need in order to actually scale up to a functioning quantum computers. So given that, I think our timelines are starting to decrease. People used to always say, oh, it's another 10 years and another 10 years. 10 years ago we were saying 10 years, now we're saying 10 years. But I think now we're maybe shortening that. I'd say within 5 years we might be able to see something where you can really say, yep, this is quantum performance, this is quantum advantage. So there you go, that's my prediction.
Right.
What do you think?
I think that in the next, up until 2030, most companies that are making quantum computers have on their roadmap that they are building something that is sort of the platform for the next phase, meaning this is sort of the scalable unit that you want to build. And you can imagine as a single GPU in a large GPU data center. So once you have that one GPU, you know how to make the next 100. You just need to figure out how to interconnect them and make them talk to each other, which is also a challenge. But that will be around 2029, 2030, in my opinion. A lot of companies will have something ready. And then during 2031, 2032, they will start connecting them. And then we will see how that works out. And then the journey will be the end of 2030s, start of 2040s. The quantum computers will just continuously improve, exactly like the classical compute. Every year you will see, wow, there's the next generation, there's the next generation, there's the next generation. I'm completely sure that will happen.
Isabell.
Yeah, of course you will not hear any timeline on my side, but I think what's very positive is that we are also already talking about not if a quantum computer will come, we're just talking about when will it come. So it just shows that we are very certain that it will come at a point in time. So now that's a matter of fact now of some years. But what also important is for us is that the ecosystem on quantum computing is created. And therefore this is something we are engaging a lot with, because we know this is a huge transformation which is ahead of us, and the opportunities with quantum computing are great. And nobody will be able to do it alone. So therefore we need a strong ecosystem. And you might have seen that we even don't go along in the mobility sector. We have, last year, we have partnered together with BMW in the automotive industry. And we have launched this quantum mobility quest, where we have defined together problem statements, because we have common problem statements about simulation capabilities on corrosion, for example, or on logistics or something like this. And we have put it out and asked the ecosystem to solve these kind of problem statements we have announced. And I just wanted to mention one thing. Industries tend to be a bit arrogant, that we know everything, we know our problems best. And I think this is also very dangerous. So we have added a fifth problem statement, and it was the golden app. It was the question to the ecosystem to say, tell me, you are the experts, you have algorithm at hand, tell me what can you offer to us what we are not yet aware. And this has been super exciting results, and we have seen really a huge uptake of the ecosystem with participation across the globe and also from all sectors. Huh?
Right, I see. One thing I would love to know from you, this is available to anyone to answer. I don't know, maybe Shohini, if you wanted to have a crack. But the same debate that we have around generative AI regarding ethics, are we about to invent artificial general intelligence that could threaten the world or humanity in some way, start, firing off nuclear missiles or what God knows, or someone using it to invent a bioweapon, for instance. Is the same ethical debate being applied to the quantum computing sector or industry or research area? Are you having those kinds of same debates in this sector? You mentioned, for instance, cracking cybersecurity, cracking military-grade encryption. Obviously, there are nation-states out there who'd quite like to crack all of our encryption. Is that debate happening in quantum industry?
Not as much as it should happen, I think. It is happening, and absolutely it is well acknowledged that quantum is absolutely a dual-use technology, and the initial funding investment by different governments around the world absolutely was driven by the potential applications in security and other military applications. But I think in more recent years, countries are now learning from AI to think about building out some kind of an initiative to try to build out what we call anticipatory kinds of discussions, where we try to think about what would be those inadvertent uses that might be perhaps not so great for society.
Right.
Who would have access to the technology? Who would be accessing the data, as well as are we increasing the digital divide? We already know we have a digital divide, so is this going to help it or hurt it? I think in Europe, actually, there's already quite a conversation happening. There's the Open Quantum Institute that has members from actually all around the world working on this area. In the Netherlands, there is activities, and in Canada, we have a Center for
But it's
Responsible
probably
Quantum.
more of a rarefied debate compared to whether or not you have ChatGPT on your phone or not. It's probably a different kind of debate, effectively, isn't it? I have one more question. Sorry, Morten, I know that Novo Nordisk Foundation will invest around $200 million in quantum computing startups. What do you expect to get for your money?
Yeah, this is our investment arm, Novo Holdings, that has recently gotten a mandate to invest in quantum startups. Basically, they are measured on return of investment. So they are going for the money. But they also have a mandate to build up the ecosystem. So some of the activities they can reserve for that. But they are also working actively to actually secure this sort of regional excellence, meaning that we want Denmark, the Nordics, Europe as a whole to become successful in quantum and not miss out like we did on AI and the computing technologies back in the day. So this is more like a concerted effort to make sure that there is enough VC funding in Europe for the companies actually to stay as scale-ups and grown companies.
And is Airbus willing to fund startups in the quantum space, yes or no?
So we are working together with academics, with startups, with companies. So we have a wide range. So it needs to be the right stakeholder, the right player, which can deliver value for us. Huh?
Right. Well, we'll have to see whether or not. Perhaps you'll be breaking the news with me soon enough. That would be nice. You'd be able to be in touch. But ladies and gentlemen, please thank our panel on quantum computing, and I shall see you tomorrow at GITEX. Thank you.